So in this video, I'm going to introduce the idea of translations and reflections. I feel like if we develop your intuition on this, then you are going to be like fire when we get to actually graphing. So we're going to break this into pieces. So first we're going to start with vertical translations. So to illustrate this idea, I think we'll just use the website desmos.com, which is like my favorite graphing software. So, okay, this black dotted line is x squared. So this is going to be our base graph. Okay, so to develop our intuition, I am now going to take a look at x squared plus 2. Okay, so just watch what happens with x squared plus 2 in relation to the black dotted graph. Okay, so x squared plus 2 has moved up 2 units, right? But it still looks like x squared. So if I zoom out a little bit, that still just looks like x squared. It looks like it was just moved up. Okay, cool. So let's take a look at then, what about x squared minus 4? Okay, so I have a look at x squared minus 4. Now it looks like x squared has moved down 4 units. Okay, so I feel like we probably are getting the intuition with this. So just to check your own intuition, what do you think is going to happen if I do x squared plus 1? Well, then I think it's going to move up 1, so let's check. Ta-da! So yeah, it moves up. This point right here is 0, 1. So, okay, so this is really an idea of how vertical translations work. And so here's the thing. This is how it works with like all graphs. So if I choose something else, like let me get rid of the graphs that I just had and I've replaced it with some other graphs. Okay, so I might not know what the graph of e to the x looks like, so I'm just going to show you. Okay, but check this out. So now e to the x plus 4, just from what we've learned, let's see what happens. It's moved that graph up, and we're going to assume that it's moved up 4 units, and I know it has moved up 4 units. So this is actually a really powerful idea because this works for any graphs. So if I wanted to do this with, say, like absolute value, so here's my absolute value function, so then check this out. If I want to look at the absolute value of x minus 4, what do you think is going to happen? It's going to move down. Boom. Okay, so this is the first idea. And the one thing that I want to point out here before I formalize this, I want you to just kind of internalize this is the idea of a number outside of a function. I'm going to refer to this idea a little bit later. So you've got the function itself and then this number on the outside. We'll compare this in a second. So just keep that in the back of your mind. Okay, so if we want to just talk about then how vertical shifts work. So you have some function f of x, then g of x, if g of x equals f of x plus k, so k is like adding something to the outside of the function. This describes a vertical shift of f of x where plus k moves k units up, so the function will move k units up, and minus k moves k units down. We'll move the function k units down. All right, so just to check our understanding of this then, without graphing it, what do you think will happen if I have the square root of x plus 6? Well, this will be the graph of the square root of x shifted just 6 units up. So that's vertical translations. So now let's pivot to horizontal translations, and we're going to do the same thing. Okay, so for horizontal translations, I'm going to use the absolute value of x. So this is going to be just our starting place. Okay, so I actually would love it if you would commit and write down, just make a guess. What do you think is going to happen if I take the absolute value of x plus 2? Is it going to move up, down, left, right? Is it going to move diagonally? I want you to like make an actual guess here. Okay, so I'm going to show you now. Hopefully you actually wrote that down. This is like always the best way to really develop your intuition. Okay, the absolute value of x plus 2. So this is a number that is inside of the function. So hopefully this makes sense. So before I had numbers that were outside of the function, this is putting a number inside of the function. And when I did that, look what happens. It did not move 2 to the right, it actually moved 2 to the left. So it moves 2 in the opposite direction. And, you know, if you said, oh, I thought it would have moved to the right, I 100% agree with you. Like, that would have probably been my guess too if I were not the omniscient math teacher here. But it doesn't. So it's just this is the way that horizontal translations work. And it just works the opposite of what you would think. And that by itself, like even if you made the wrong guess, like now knowing it works the opposite, like that still creates intuition, right? So we're still developing it. Okay, so then what do you think is going to happen if I take the absolute value of x minus 4? Okay, well, then we're probably going to move right. So let's see. Boom. Okay, so here I am. Boop, boop, boop. Move 4 to the right. Cool. Okay, so then just to kind of finish this off, what about the absolute value of x plus 1? What do you think is going to happen there? All right, so it moved 1 to the left. Okay, cool. And so if we were to look at this with like other functions, so again, this is like one of those concepts that just works with like all functions. So we're like really cracking this kind of cool code. So maybe you don't know what the graph of 1 over x looks like, so I'll just tell you it looks like this. But okay, so once again, here's the idea of me adding a number on the inside of the function, like with the x, or attached inside with the x. So in this case, so this always moves in the opposite way. So if I write plus 3, then I think it's going to move to the left 3. So let's just see if it moves left from the original function. Yep, certainly moved to the left. Okay, so we're feeling better about this. Or if I had, so let's look at like the square root of x. So if I have the square root of x minus 1, so now, let's see, is it going to move left or right? Should move to the right. Boom. Yep, so totally works that way. So how horizontal shifts work, so if you have some function f of x, then if you have g of x equals f of x plus h, so I always think of this as adding a number inside of the function. This describes a vertical shift of f of x where if you have plus h, that moves the function h units left, minus h moves 8 units, or h units right. Okay, so just to compare the two definitions now. So we have the vertical shift, which is like adding this number outside, which is where we started. And now we have the horizontal shift, which is adding a number like on the inside. That's really like the way I break it down, I guess, in my head. Okay, so that being said, how would you interpret this function? So I've got the cube root of x plus 3. What is going to happen in this case? Well, hopefully you took a second to maybe write down a guess. If not, I would say pause and just write something down. So this is plus 3, which means that I am going to be moving, let's see, hold on, I'm having a computer issue. Sorry, okay, 3 units left. Okay, so cool. Now let's talk about reflections over the x-axis. All right, so now I'm going to take the square root of x. And so we're just going to see what happens then if I put a negative in front of the square root of x. And you might already have a guess as to what's going to happen based on the description. So let's see. So if I put a negative in front, it literally takes this and reflects it over the x-axis. And by now, you know, this is like, again, one of those like codes. So this works with like all functions. So if I wanted to compare this idea, say, to some other function that maybe we don't know, like 1 over x squared. So if I put a negative in front of that, so look what happens. It dumps the whole thing over the x-axis. So once again, this is like kind of part of that like code in graphs. So now we can talk about how reflections over the x-axis work. So for any function f of x, g of x, which equals negative f of x, this describes f of x just reflected over the x-axis. So I think this one is like kind of straightforward. So if I had, let's say, f of x equals negative x squared, and if I ask you what does this look like, so you would tell me then this is a parabola flipped over the x-axis, or another way to visualize that is that this is literally an upside down parabola. Okay, so now we've kind of unpacked this code, and I really want to get us used to reading this code, because once you know this code, it makes everything so much easier. So what we're going to do in the next set of examples is we're just going to describe any shifts or reflections, and that's all we're going to do. We're not going to graph anything. We just want to get used to messing around with the code. So just to start with this, I'll start with just 2 examples just to kind of get us going. So in this case, I see a negative here, so I know that this is going to be a parabola flipped upside down, and then this would be a number on the outside of the function, so that's going to move up and down. So maybe I'll just like color code these or something. So this is going to be x squared reflected over the x-axis, and this is, we'll say maybe instead of translated, we'll use shifted. Shifted and translated are the same thing, so shifted 3 units up. So I just color-coded those so that you could see what comes from what. Okay, so that's kind of what we're going to be doing. So now with this next one, so this is a great one because this really allows you to see now the difference between a number, like that concept I keep bringing up of like having a number inside or outside the function. So this 2 is inside of the square root function. This -1 is on the outside of it. So this +2 means that we have the square root of x shifted. Okay, so it's +2, so that means it's going to move left. Shifted 2 units left. And then this -1 means it's shifted 1 unit down. Okay, so let's take a look now at C here. And I would strongly encourage you maybe just to pause here. I think this is a great place just to check that you're kind of understanding the basics. So just describe any shifts or reflections and then hit play when you're ready. Okay, so now in this case, this -5 means that my graph is going to shift 5 units to the right. And then this +2 means we're going to shift 2 units up. Okay, so now what we're going to do is we're just going to incorporate what happens when I have a negative here. Okay, now I am going to, so just to review, right? So when we have that negative, so that describes a reflection. Now, in the way that this particular graph is going to work, this negative does still kind of indicate the idea of kind of flipping over the graph, but it's no longer going to be like a perfect reflection over the x-axis. And so I guess what I'm trying to say is that when you're out in the wild and you see a negative like we see here, the big thing that you really want to remember about this is that this flips the graph upside down. So some books are going to say reflections. I like the word flips because that kind of indicates, you know, the way that my brain works, I guess. So this means this is going to flip upside down. And then what about the +2? So this means that we're going to move 2 units to the left and then 5 units up. Okay. So now that we've discussed that, and this is like, I'm going to use the word flips. Sometimes I say the word reflects. I kind of go back and forth between the two. So to end, here's one more for you with another negative. So maybe just pause here, make sure that you feel solid on this, and then hit play when you are ready. Okay, so we've got the negative here. So this is going to flip. The -1 means that I'm going to move 1 to the right, and then the -4 means that I will move 4 down. Okay, so we are going to keep going with this skill in the other videos. So I am going to leave you at this, and then we'll keep progressing the skill in the next part of the series. So thanks for watching. I will talk to you guys next time.